Hello, and welcome to our lesson on solving problems with the area of a triangle. So in this lesson, we're going to use a formula for the area of a triangle, which is given as 1/2 of AB sine C, where we have the side length A, which is this one, opposite the angle with a capital letter, B, which is opposite angle B, and the sine of C, which is this angle here. So all we need are the two sides between the given angle. So we can use this to work out the area of this triangle. Because we've been given the angle 32, I can label this vertex C. We can label the others A and B. And opposite the angle A, I label lowercase a. Opposite the angle B, I'll label lowercase b. And this is lowercase c. So now I can use a formula where the area is 1/2 of length A, which is the 8, times B, which is 10, times the sine of the angle 32. Now I can tidy this up a little bit. 1/2 of 8 times 10 is 40. So the area is 40 sine 32. And I can work this out on a calculator to get 21.2 centimeters squared. Okay, let's try another question. So in this question, because we've been given the angle here, I'm going to label this vertex C, so then I can label A and B on the other vertices. We'll label the sides as well, so lower cases A and C. But now to work out this area, I need to either know the length of a line B, because then I've got two sides and the angle between them, or the angle B, for the same reason. But because I've been given a matching pair of angle and length, I'm going to use the sine rule, and this will give me angle A. So from this, I can use angles in a triangle to work out angle B, and then I can use these two for the area. So we'll begin by working out angle A. Using the sine rule then, I can say the sine of C, which is sine of 62.5, over the opposite side, 5.8, is equal to the sine of A over 6.2. Now to work out what sine of A is, I can multiply both sides by 6.2, because then these will cancel. So now I have 6.2 lots of sine 62.5 over 5.8. And this will give me the sine of A. So working this out on a calculator, I get 0.95 to 2 decimal places. And then to work out A, I take the arc sine of both sides. These will cancel. So angle A is 71 degrees, which I'll write on our diagram here. Okay, so now I have these two angles. I can use angles in a triangle to work out angle B, which is 46 degrees. And now I can use these two lengths with this angle to work out the area of a triangle. So we have the area is 1/2 of 6.2 times 5.8 times the sine of 46. And this gives us 12.9 centimeters squared to 1 decimal place. Okay, let's try another question. Okay, so in this question, we've been given the area of a triangle is 214 centimeters squared. The length of AC is 45, and the angle A is 34 degrees, and we've been asked to work out the length AB. So I'm going to use a formula where the area is the product of the two lengths either side of the angle. So we'll call this B and this one C. So 1/2 of BC sine of the angle between them, which is 34. We know the area is 214, so this is 1/2 of B, which is 45 centimeters, times c, which we're trying to find, the sine of 34. I can tidy this up by moving the half to the left-hand side of the equation. So 428 is 45c sine of 34. So now I'm going to divide both sides by 45 sine 34. So these will cancel. So the length c will be 428 over 45 sine 34. And this works out as approximately 17 centimeters. Okay, let's try one more question. So in this question, we've been asked to work out the area of this blue region. And you can see that in this region, it's the difference in area of the triangle ABC and the sector with a radius of 5.4. So I'm going to begin by trying to work out this angle here, because I can use this for both the triangle and the sector. So we'll label this here and here. We've been told in the question that A to B is 13 centimeters, and B to C is 18, and A to C is 11. So now we can use the cosine rule to work out cos of A, which will be the cosine of this angle. So we have A squared is equal to B squared plus C squared minus 2BC cos A. So to make cos A the subject of this formula, I'm going to move the negative 2BC cos A to the other side of the equation. And now we'll move the positive A squared to the right-hand side by taking it away from both sides. And then we'll divide both sides by the 2BC. So to work out the angle A, I'm going to substitute the lengths B, C and A into the right-hand side of our equation. So this gives us cos A is equal to negative 0.1189. So next we'll take the arc cos of both sides to work out the angle A, and this is 97 degrees to the nearest degree. And I'll write this on our diagram as 97 degrees. So now to work out the area of the two shapes. Well, the area of our triangle is going to be 1/2 of these two lengths, which are 13 and 11, times the sine of this angle, which we've worked out is 97. So the area of this triangle is 71 centimeters squared. The area of our sector is the fraction of a circle, so 97 degrees out of 360, times pi r squared, and the radius is 5.4. And this works out as 24.7 centimeters squared. So the difference between the two gives us the blue region with 46.3 centimeters squared. Okay, thank you for watching, and I hope you found that useful. Thanks again, and take care.